So my name is Jess and I work in the Centre for Plastic Electronics at Imperial, where I create new organic light-emitting diodes out of carbon-based materials. We use long chains of carbon atoms, which are called polymers, and we mix them with small spirally shaped molecules so that we can control the polarization of the light that's emitted. And I'm really interested in light-emitting diodes that can emit circularly polarized light, because this is really super fascinating for next generation displays so that we can make them even more efficient than ever before, but also have kind of new functionalities where we can start to image things that might be dependent on the circularly polarization of the light that we excite them with. So it's super exciting. At the moment, organic light emitting diodes in televisions, which are already in lots of displays. If you've got a lovely expensive television with really, really high resolution and great colors, then you have an OLED display. But we have a circularly polarized filter in there to stop any ambient light distorting the image that you get. So if you're watching this on an OLED TV right now, there's a filter in the screen, and that means that light from behind you goes through that filter, becomes left or right-handed, hits off the back, that handedness inverts, and then it can't get out of that filter again. So it stops all that ambient light distorting the image. But what we're doing in that is losing half of the emission from a pixel. A normal pixel would emit unpolarized light, try and get through that filter and lose 50% of it. So what we're trying to do is create pixels within that OLED TV that actually emit circularly polarized light that can sneak through the filter. It's great fun. I work in kind of experimental science, so every day I work with material science physicists and chemists. And we all come together and the chemists give us some bizarre materials that they've been working on or developing, and then we as physicists go off and think about new ways that we can process them, new devices that we can make, new ways that we can study them, and then we meet up with our materials friends and discuss the kind of characterization results and start to think about the way we could analyze these and the models that we could create to understand what's going on. And then we go and talk to the chemists again about informing the next generation of materials that they do the synthesis for. And I've said that like it all happens over the course of the day, but really synthesizing new molecules takes a couple of years to get right. But we can go to special shops and buy new materials if they're taking too long. So yeah, I think the fun part of my job is working between like very, very small little molecules and trying to work out exactly what they're doing, but then also talking to people and working with people all the time as well. And actually we rely a huge amount, and chemists rely a huge amount, on using computational models to build things. I would tell myself to learn how to program, because it's actually really, really important and useful. And when you study something at university, it will make your time studying infinitely more efficient and enjoyable if you know how to sort your stuff out on your computer, but also code so that when you get data or want to analyze something quickly, you have a really, really easy platform to do that on. And unfortunately, when I went to school, we were not taught how to do that at all. So if I was my young self now, I'd be like, woohoo, we can learn computer science, that's great. And I would keep doing subjects like maths, because maths is so important later on for understanding different systems, for being able to see a relationship between two different variables. And I think that at the moment in school, it's really hard to see how it relates to different subjects. Maths, you don't see the relationship between maths and physics and maths and chemistry and maths and biology, or maths and design technology. But actually, it's a really, really important skill to have. So I would say, little young Jess, please keep trying to work out how to multiply two matrices together, because this might help you later on in life and you shouldn't be frightened of it.